Also, I agree and take this call, right? So, is that just six? If you this teenage. Oh, the community, yeah, it's between sales. Oh. Yeah. Points where everything is. That's something like this. Something other. I probably took. That's true. I was the last one that I it's had you're gonna try. You're gonna try that's really good.
Good morning, everybody. So picking up from where we left off in the last class, we were in the file system notebook, and we were just about to talk about path names. So a path name is simply the name of a file that uniquely identifies the file on the file system. Okay, so name of the file uniquely identifies the file on the file system. So you have two different types of path names. There's an absolute path and there's a relative path. So an absolute path includes all of the directories that lead to the file itself, right? And that means it starts at root. So here are some examples of absolute path names, right? Now remember, directories in Linux are just files, right? They are files, they're special types of files, but they're simply files. So you can have the path name for a directory, which is the unique location of the directory. So the unique location of the root directory is simply the // right? Remember, // not the // If you want to know the absolute path name of the bin directory inside of root, right? You always start at root. So root and then bin is the name of the absolute path for the bin directory. If you look in the bin directory, there's a program called ls. So there's another file called ls. The absolute path name of ls is root, then bin, then /. So remember, the / is the directory unless it's the first character in the path name, it's a directory separator. So root directory, bin, /. So that's a directory separator. And so ls is the would be the complete absolute path of the program named ls. And for this particular notebook on my computer, the absolute path name starts at root, then it's home. sys220 is a user on my computer. Right? Big sys220 is a directory name. Notes, another directory name. Bash, another directory name. And finally, the name of the file is filesystem.ipynb. Right? So the absolute path includes all of the directories leading to the file itself. Now, you can use absolute paths wherever you need a file name. Right? So if some program needs a file name, if you want to find information about a file using ls or something like that, or if you want to switch to a directory, you can always use its absolute path name. But the absolute path name is often very long, or can be very long, right? And so you don't really want to type in root, home, sys220 notes, bash, file system, ipynb, especially if you're already in the bash directory, because inside the bash directory, there's a file called filesystem.ipynb. It would be nice if you could just say filesystem.ipynb, and you can, right? And so that's what a relative path is. So a relative path includes all of the directories that lead to a file starting from your current working directory, right? So suppose our working directory is root, right? I'm going to talk about dot in just a second, right? And you would like to know what is the relative path to the bin directory located in the root directory. Well, I don't have to say /bin. I can just say bin, right? I'm in the root directory. If I want to find information about bin or switch to the bin directory, right, I can just use the name bin instead of /bin. Right? If I want to know where the ls command, if I want to the absolute path of the ls command from the root directory, It's just bin/ls. Right? Again, you don't need the leading root directory name. Right? So the relative path name changes depending on what your current directory is. Right? So if my current working directory is home sys220 sys220, right, then the relative path of the notes directory, so the one that's inside sys220, is just notes. Okay? The name of the file system notebooks from the big sys220 directory is just notes/bash/file system IPYNB. Right. So the relative path starts at the current directory, and then you you specify the rest of the path that leads to the file you want. Now, when you're using relative paths, there are two special directory names that you're allowed to use. Right? And so one of the special directory names is just dot, the period. Right? And so the period is the name of the current directory that you're in. This says it's the root directory, but that's because we're in the root directory right now. Right? So dot is the name of the directory that you are currently in. So if I switch to here, right, you can see that I'm in my home directory. Right? If I type in cd dot, right, dot is the name of the current directory that I'm in. So it's just the directory root home Burton. Right? And so if I print the working directory again, it does nothing. Right? This says switch to the current directory, which does nothing. Right? Similarly, every directory knows where its parent directory is. The name of its parent directory is ... So if I do cd ... right, and then print the working directory, I'm now in root home. Right? I've gone up one directory to the home directory of that directory there, right, which is just root home. Right. So one more time, let's do something like this. All right. So now I'm in the notes directory. I guess this is slightly different than what's in the notebook, but that's fine. Right. So cd ... does nothing. Switch to the current directory. Right. cd ... go up one directory. So that goes back to my home directory. Go back to notes. And now you can use dot and dots as part of your relative path name. So for example, I can do cd ... Right? So that goes up two directories, right? Go up to the parent of the current working directory, and then go up to its parent directory. Right? And so if you do that, you see that you're now in root home. So, oops. All right, let me clear that. Okay, and similarly, you can use dot in the same way. So here you see we've got directories called bash C and Jupyter C kernel. So I can do cd ... /bash, right? So dot, name of the current directory, right? Go into the bash directory. Right? And we're now in the bash directory, right? You don't need the dot in this case, right? You can just do cd bash and everything's fine, right? But if you, oops, sorry, Linux is case sensitive, so you have to make sure that the case matches the name of the command. Okay, so what was I doing? cd bash, right? So here you don't have to use the dot here, right? It's the same thing as just writing cd bash in this case, right? But dot is the name of the current directory, right? ... name of the parent directory. I guess we can do some more things with ... So let's do. So if I go up, that takes me into the notes directory, right? And I know there's a C directory, so I can do /C. And that will take me into home Burton notes C. So there are the C notebooks for the course. Okay. So ... is just the name of the parent. Dot is just the name of the current working directory. You can use them as many times as you want inside of a path name. So for example, cd ... /... is fine, right? Switch to the current directory and the current directory and the current directory and the current directory and the current directory, right? It goes nowhere. The dot is often useful when you're specifying a file in the current directory. So for example, I've got a bunch of notebooks here. If I wanted to edit one of these notebooks using a text editor that I don't recommend any of you use right away, I can write dot, say, a simple C program like that. right? And that will open up the file a simple C program.ipynb. And so there you can see the contents of one of your notebooks. Okay, so you'll be using dot more in the coming weeks. Dot is useful for specifying path names. So questions 1 and 2 of your assignment, have you used dot and dot dot? Does it have you used dot? Has used dot dot anyway. Okay, so a little bit more about the cd command. So you're going to be navigating your directory structure a lot, especially in assignment 1. If you're ever using the command line interface, you're going to be using it a lot because you're going to have to be switching. You'll want to be switching directories to move to the files that you want to access. So cd on its own, so far when we use cd, we've always specified a path name to move to a directory. But on its own, cd changes to your home directory. So here, I'm currently in home Burton Notes C. If I just type cd on its own, that takes me to my home directory. So that's nice, right? That's a quick way to get to your home directory if you're somewhere else. There's the symbol tilde. So they're going to be different on all of your keyboards depending on how your keyboard's laid out. Mine's in the upper left-hand corner, and you need the shift key to get to it, right? But it's the symbol that looks like a little bit like a little wave, right? Tilde turns out to be what's called an expansion in Linux. And so tilde expands to the name of the user's home directory, right? So when you write cd space and then tilde, what happens is the shell interprets the tilde and replaces it with the absolute path of your home directory. So this is effectively the same as writing cd root home / and in my case Burton, and that will also take you to your home directory in this. So let me go somewhere else. So again, we're in the C directory. If I type cd tilde, that takes me to my home directory again. So tilde is a useful way to specify the name of your home directory, especially when you start to write scripts. So we'll get to that in a week or so. Dot and dot dot, we now know what they are. Dot is the name of the current working directory. Dot dot is the name of the parent to the current working directory, right? And there's some more examples here of using dot dot. Right. I'm going to stop there. I guess I will stop there. There is a hyphen as well. So if you've been using cd to travel through your directory structure and you want to go back to the previous working directory, you can always use cd space hyphen, and that will go back to your to the previous working directory. Okay. Oh, wrong one. Where are we? Oh, I haven't started the. Okay, so we're now into the next lecture. So I'm now going to explain more about how commands work in Bash and give you examples of other commands. If you want the notebook corresponding to this particular lecture contains all of the examples and more. Right. So if you want to look at the notebook, everything in this lecture is going to be there. All right. So commands can be one of 4 things in Bash, right? And so they can be a built-in command. So a built-in command is a command that the shell knows natively. Right. Things like cd and pwd are often built-in commands, right? So Bash knows about those commands on its own. Most of the commands that you'll be using are things called are just executable programs. So it's a program that you can run, right? And you can write these in whatever language you want. So you can write in Python, you can write it in Java, most of the Unix commands are written in C, right? But you can write these in whatever language you want, produce an executable program, and then you can run that as a command. Oops, sorry. There are things called aliases. So an alias is just it's an abbreviation for typically a much longer command, right? And so I can create what's called an alias. I give it a name, and then I can tell it what command does that name actually correspond to. I don't actually show you how to make these in this course. If you want to, you can look it up. It's pretty easy how you make one, but I don't actually show you how to create an alias in this course. They are useful. Many of the commands that you use from your command line, it turns out they are in fact aliases already. You'll use them whether you know it or not. And then finally, you have these things called shell functions. And so you'll be writing these, I guess, around week 4 or 5 of the course. You can write a function in a shell scripting language. So you can write a function in Bash, store it somewhere, and then call that function from the command line as though it were a command. Right, but most of the commands you use are 1 and 2. 1, 2, and 3. Right, it's either a built-in from the shell, it's a separate program that exists somewhere on your in your file system, or it's an alias of some kind. And the alias will refer back to either one. Will refer back to something that's either a built-in command or an executable program or a shell function. Okay, if you want to know what kind of command is this, so is it a built-in, is it a regular command? Is it a alias? Or is it a function? You can use the type command. This is not super useful, but if you are curious about this, you can in fact use type. Right, so type ls. So this ls turns out to be an alias on my computer. Right, so it says here ls is aliased to the command ls -- color equals auto. Right, and so when I type ls on my computer, I get colored output, and that's because on my computer, ls actually means this. Right, this -- color equals auto tells ls to use the option color and do automatic coloring of the output. Right, so if something's a file or a directory, it gets colored differently. Stuff in green are special kinds of files. We don't need to worry about them right now. So if you type cd, it tells you it's a built-in, and so on and so on. Is there another example here? Type la. Okay, so I guess we can do that. All right. Okay, so LA turns out to be another alias on my computer. On many Linuxes, this alias exists. And so here it says LA is actually alias2 ls - big A. And so we'll see what that does later in the lecture. Right, so if you want to know what kind of command is a command, you can use type. If you want to know what is the path name of the command, you can use which. Right, now, in order to get the path name for a command, the command has to be a regular command. So which ls tells you is actually the program root user bin ls. Right. Okay. Which la will tell you nothing. La is an alias. Notice it's slightly confusing here. Ls is also aliased on my computer, but because the shell knows, or because which knows that ls is actually a command, is also a command, it actually tells you the name. It actually tells you the path name of the command. Right? La is not a regular command. It's actually an alias, so it tells you nothing. And finally, which cd. Remember, cd is a built-in, so there is no path name. There is no program that corresponds to cd. Right? It's something that the shell knows how to do on its own, so there's no output again. Oops, sorry. Okay, so now we're going to learn a little bit more about ls. So ls is going to be one of the commands that you use very often. Right? It's also one of the commands that you're going to use a lot on assignment number 1. Okay, so ls on its own lists information about the current directory. Right, so what directory am I in? I'm in my home directory. So if I type ls, right, it lists all of the files that are in the current directory, right? So it lists all the files in my home directory. Notice my home directory is a mess, but that's because I make lots of temporary files to demonstrate stuff in this course. Okay, if I type in the name of a directory, it lists information about that directory. So if I type in ls dot, right, remember dot is just the name of the current directory, so that's going to produce the same output as just ls. Right. Let's see. So I have a whole bunch of directories here. So let's see what's in 2024 winter. Right. So again, if you use the name of a directory, it lists the files that are in that directory. Right. So in my 2024 directory, there's a 2024 fall directory. There's an assignment 4 and an assignment 5 directory. I don't know if there's anything inside of, say, dir 00. So if there's nothing in the directory, or if there's seemingly nothing in the directory, it prints nothing. Right. So there's nothing in the directory dir00. So it outputs no information. Now remember, inside dir00, right, there really are two files. Right? There's the file name dot, and there's the file name dot dot. Right? Remember, dot is the name of a directory. Dot is the name of the current working directory. Right? Dot dot is the name of the parent to the current working directory. Right? It turns out that in Linux, every directory contains dot and dot dot. Right? Normally, you don't see them when you use ls. Right? So notice when I type ls in my home directory, I don't see a dot or a dot dot file. Right? If you want to see dot and dot dot, that's what the -a are. The -a variations are for. So minus little a. Right? Notice that the output now changes. Right? There's dot and dot dot, and there's a whole bunch of other files that begin with a dot. Right? So there's a bash history, there's a bash logout, there's a Jupyter, right? There's a local, there's Mozilla, so that's my Firefox configuration directory. So any file in Unix that begins with a dot is considered to be a hidden file. Right? So dot and dot dot, they both begin with dots, right? So they are considered to be hidden files, right? Dot bash history, a hidden file. Right? Hidden files are simply that, right? They're hidden from the user unless the user asks for them specifically, right? So commands like ls normally don't display information about the hidden files. Right? Hidden files are typically used as configuration files for other programs, right? So for example, or configuration or storage for other programs. So the bash history .bash history file contains information about the commands that I've typed into my into the shell. Jupyter contains information that Jupyter needs for its own configuration. So when it starts up, it reads and writes a bunch of information into that directory. Right? .mozilla is where Firefox is storing all of its information. So all the cookies and its cache and everything, it's somewhere in that directory somewhere. Right? So hidden files always begin with a dot, normally not displayed by ls unless you ask it specifically. Right? -a means show everything, including the hidden files. -big A almost means the same thing. Right? So -big A is show me everything, including the hidden files, but not dot or dot dot. Right? Everybody knows that dot and dot dot exist in a directory. So it's often not useful to produce to output that information, right? So little a, show everything. Big A, show almost everything, not dot or dot dot. Okay, ls will list information about not just directories. It will also list information about files. Right? So if I switch into root bin and then look at the ls command, I can ask ls to display information about the file ls. cd root bin. Right. So notice there's a whole bunch of files in this directory. Right. If I type ls, right, I'm using the ls command to list information about this file named ls. Right. And here it just says, well, there's a file named ls, and it doesn't give you back any more information. Right. If you want more information, we can get that. I'll show you how to do that in just a second. Right. Now, what happens if you type in ls and ask for a file or a directory name that does not exist? Ls does not exist, right? You get an error, right? So here you actually get an output. You actually get some sort of message. It says cannot access, does not exist, no such file or directory, right? So if you pass in the name of something if you pass in the name of a non-existent file, ls does not display any. ls tells you that's an error. Again, you can use absolute or relative paths when you ask for information about a file. So I can use ls bin ls, right? So that's asking to show information about that file, where that file is given as an absolute path name, right? And so it just says, well, there's a file called root bin ls. You can use a relative path. What directory am I in? Hang on. I'm in bin. So I can do ls up home, Burton, and then dir0. Like that. Oh, I guess I can't. Sorry. dir 00. There is a dir 00. What's going on? It's right there. Strange. Why can I not do that? Yes. Sorry. What's up?
I believe it's because it's in dir and then dir 00, which is why when you write ls.home/burn/dir, it is returning the list of directories.
It is, but then I typed in the 01 here.
I believe it's in dir/dir 00.
No, it's not.
What the?
I know for a fact it's not. Hang on. Oh, right. So I should be able to list information about any of these files. So file1.text1. Oh, that's weird. This is the problem with this course. Whenever I do something live, it doesn't always work. It should be able to display information about this file. For reasons I don't understand at this particular moment, it can't. So we'll come back to that, I guess, shortly. No, we're here. We're in bin, so I can do ls up. Oh, that's weird. You can, in fact, do this. I know for a fact you can do this. Oh, no, that's not it. Okay. There's ls. Up. That works fine. Oh, wait, where'd home go? I hope I didn't delete my home directory. Anyway, games. Oh, you know what? What direct? Oh, hang on. No, all right. Where did everything go? There's home again. Strange. All right, ls. Let me go into my home directory. Okay. Up. Okay, so we can. Do I have access to that? There we go. Okay, so using .. right? You can specify the name of you can specify a relative path name, right? And so here I'm asking for information about the directory Homer Simpson. So there's a made up user on my computer called Homer Simpson, and you can see inside their account there are some files here. Right. Okay, so ls can list information about a directory or information about files. Right. All right, so when you list information about a file, it just says the file either exists and this is its name, or it says nothing, or it complains and says that file doesn't exist. So if you want extra information about a file, you have to ask for it. So here, we're going to use the option -s to find out how big is the file. Okay, so we got a bunch of files here. Let's find out how big another file is. Right, and so it says 4. Doesn't tell you for what, it just says 4. Right. Okay, so it turns out that unit, the unit in size it's giving you is something called a block. Right, now it's not important for our purposes exactly what a block is, and in fact, the size of a block changes up depending on your computer and how you've configured Linux. So if you want something that's readable in some sort of human readable unit, there's the H option. Right, so ls -s for size, -h, human readable, another file, and now you can see that it's 4 kilobytes long. Right, so roughly 4,000 bytes. When you're using options, you can specify them separately. Right, so here I've specified two options. Most commands will allow you to merge the options. So I can write ls -sh instead. Right, and that does the exact same thing. Right, so use both the S and the H options to list the size of that file in human readable units. Okay, so when you use a command in Linux, it's always name of the command, or more precisely, it's the path name to the command. Right. Many of the commands that you'll be using in the course, Linux knows, or your operating system knows where that command happens to be stored on your disk. Right, so it knows where it is on your file system. So you don't have to write in the actual path name of the command. Right? When you start to make your own commands, though, you either have to tell your operating system, where is this command, or you have to specify the path name to the command. Right? But for now, it's just the command. Right? If you anything in italics is optional. Right? So for most commands, you can just type in the name of the command and it will do something. Right? For many commands, though, you're going to want to specify some additional input arguments. So you would specify them here. Right? There could be more than one, right? 0, 1, or more, right? And you may or may not want to use some options. So when you specify an option, it's hyphen and then the options that you want to specify. Right? So your options are optional flags that modify the behavior of the command. Right? Minus S for ls tells it to list the size. Right? Minus H tells it to list size in human readable units. Right? Arguments are a space-separated list of items on which the command acts. Right? So if you have more than one argument to your command, it's argument 1 space, argument 2 space, argument 3 space, and so on and so on and so forth. ls will list information about all of the files that you specify as a command line as arguments. Right? So ls minus sh, so size of the file in human readable units. Right? I can ask for information about another file. I can ask for information about check size, and I can ask for information about the temp directory. Right? So argument number 1, argument number 2, and argument number 3, and away we go. Right? So here we see that another file, 4 kilobytes big. Check size also appears to be 4 kilobytes big. Right? And the temp directory contains files occupying 44 kilobytes of space, right? And here are all the files, right? So there's a zip file that's that big. There's a zone identifier file that's that big. This is a Windows thing. Don't worry about this, right? There's a directory that's that big, and so on and so on and so forth, right? So for every one of these arguments, ls will run with these options here. If you pass in the name of a file, it gives you information about the file. If you pass in the name of a directory, it lists the files in the directory. Right? Notice it doesn't list the files in the directories of the directories, right? So the temp directory has a directory called A4, but the ls command does not list information about that directory, right? It doesn't list the files in that directory. So it doesn't work recursively. Okay, so you can typically combine options, right? Use one hyphen, no spaces between the options, and you can merge all the options together. So minus big A, list information about all the hidden files, all the files, including the hidden files, not dot or dot dot, right? Give me their size in human readable units, and the 1 means in one column of output. Oh, there's steam locomotive again. Sorry. I gotta let it finish. Okay. So there's ls. So ls minus big A sh1. So it's going to list information about all the files, including the hidden files. It's going to give me their size in human readable units, and everything will come out in one column. So there it is. Right. Note on its own, ls, if you don't say the -1, it writes out information about the files left to right. Typically, it uses 2 or 3 or 4 columns of output, depending on how long your file names are. Right. So here I've got them all coming out in one column. We have information about the hidden files now. Right. So we have all the hidden files. We've got information about all the regular files. Notice some of these are actually 0 bytes big, so they are empty, and so on and so on and so forth. Or you can specify them separately if you really want to. It's easier to not specify them separately. Now, the problem with the options, as you may have noticed, is that there's a bunch of problems. 1, you need to know that they exist. 2, you need to know what their names are. Right? 3, if you're using, these are called the short options. They're all a single character long. it's not exactly obvious what they mean. So some commands have the long form options. Right? These are much harder to type in or much longer to type in, but they're easier to interpret what they mean. Right? So it turns out minus big A is equivalent to minus almost all. Right? H is equivalent to minus human readable. S is equivalent to minus size. There is no long form option for one column, so it's just -1. So if you wrote all of that, that's the exact same thing as writing that or that. Right? This is easier to read and remember what it means inside of a program, inside of a bash program. So a bash program is simply a sequence of bash commands, right, which you store in a file somewhere. And so the long form options are useful inside of a program because whoever's reading the program doesn't have to remember what the options mean, right? But when you're using them from the command line, it's much easier to type in that than it is to type in that. Okay, so here are some. These are only the commonly used LS options. There are many more LS options. Right? Depending on whether you're using the Mac version of LS or the Linux version of LS, there will be other options. Right? So the LS command in Mac may have different options than the LS command in the Linux. Right? So little minus a is list information about all the files, even the hidden directories. Right? Minus big A is exactly the same as minus a, but do not list dot or dot dot. Minus D is interesting. You're going to have to use this on the assignment. So there will be times when you want to know the name of a directory, but you don't want the contents of the directory itself. Right. So remember what ls does if you pass it a directory name. So ls dir 00. Oh, sorry. Let me find a directory that actually has something in it. Okay, ls notes. Right. So if you pass in the name of a directory, right, ls by default lists the files that are in the directory. Sometimes that's not what you want. Sometimes all you want to know is what is the name of the directory, right? Or does the directory exist, right? So that's what the minus D option is for. So minus D says, if this thing is a directory, don't list its contents. Simply treat notes as though it were a file and list information about the file, right? And so that does the exact same thing as if I had typed in ls file 1.txt. All right, like that, right? So minus D, if it's directory, simply list information about the directory itself. So for example, like that. Minus, this is a L, not a 1, right? So be careful with this one. Minus L means give me the long listing for a file. The long listing includes extra information about the file, right? So this says, oh, sorry, ls. This is a bad example because this is actually a link, not a directory. ls minus L, there we go. 2024. Oh yeah, that's better. That's what I wanted. So let me try that again. So ls 2024, right, on its own, prints out all the contents of that directory, right? If I want information about the directory itself, right, and not the contents of the directory, right, use the minus D option. And if I combine that with the L option, right, now I get the long listing of the information for this directory, right? So the long listing produces a bunch of symbols here, produces, oh, sorry, you have to be careful about this. There's no standard on how this information is presented. Most versions of LS will produce the output that's listed here, but depending on the version of LS that you're using, you might get different or slightly different information. So it's showing you that's the name of the directory. That is I believe it's the modification time of that directory. So when was that directory last modified? So it turns out that was September 2nd. I don't remember exactly what that is. That's related to the size of the directory. That is the group name of whoever owns the directory. That is the username of whoever owns the directory. And these symbols here will explain that when we talk about permissions on a directory. Right? But the long listing L gives you extra information about the directory. Okay, and there's a bunch of other options here that you can look at as well. Sorry, okay. Many, but not all of the commands will produce help if you ask for it. Again, notice the many, but not all, right? So ls minus minus help will in fact produce some help information for the command. Right? Often the information is quite long. So notice that, oops, sorry. Right, so notice that my version of ls has many options. Right, there's a whole bunch of them. One of the problems with using the Linux commands is that many of them have lots of options. And you, to use the commands effectively, you either have to read the documentation to find out what the options do, right? Often it's faster just to search on the internet, right? Hey, I want to use ls to do blah, and hopefully someone will have answered your question for you, and you can figure out what options to use, right? The help is available to you here, though, right? So this is another version of help available to you. In the last lecture, I showed you that there's a man command. Right? So man is the manual page for ls. This also displays help information, but it displays it in a different format. For most of you, I would recommend searching on the internet for help when you want to know about help on a command. It's probably going to be faster than sifting through all of the help documentation itself. Right? The man pages and the help stuff and the help pages are often, they're meant for people who actually know what the commands do, and they need to be reminded of what options or what the options actually do, or what options exist, right? But otherwise, they know how to use the command already. And for the built-in commands, you can either use man built-ins or you can use the help command, which is separate than the help option. There's man again. So we saw this in the last lecture. Oh, I guess this is telling you how to use man. All right. So how the heck do you use man? So man is funny. Okay. So what man does is it lists what's called the manual page for a command. Typically, the manual page is very long. So what it actually does is it lists or outputs the manual page for a command, but sends the output to another program. The other program is called less. So man ls does the following. Right? Okay, so notice that down here, this appears to be a program that's actually running. Right? So here you've got press H for help or Q to quit. So I'll show you how to navigate this in just a second. Right at the top, it gives you, okay, there's no fixed format for the ls commit for the man pages. Man pages are created by whoever created the command. All of the importance commands are written by GNU, the GNU group, so they all have a standard man page. If someone makes up a program and writes their own man page, they can write it however they want. So the standard commands always look like this. Man pages for non-standard commands will look very different. Right, at the top, you'll see the name of the command. You'll have a very short description of what it does. Right, so ls lists the contents of a directory. Right, the synopsis tells you how are you supposed to use this command. Anything in square brackets is optional. ... means 0 or more. Right, so this says ls will take in 0 or more options, right, and 0 or more file names. Right, by file names here it really means path names. And then you'll go into the expanded description. Typically in the expanded description, what you'll see are what do the individual options do. Right, so -a or minus all do not ignore entries starting with dot. Right, -big A, do not list the dot and dot, but otherwise list everything that -a does. Right, and so on and so on and so forth. All right, now notice that I can't scroll here if I try. Right, it's because there's actually another program running here. The program is called less. So less is a program that will display information, will display the contents, will display the contents of a file one page at a time. Right. So to move to the next page of the man page, there's a bunch of ways you can do it. You can press the F key. I can press the space. So that moves forward one page. Right. And now you can see there's a bunch of other options. If you want to go back, you can press B. That goes back. There's other ways to go back as well. Right. There's ways to search a man page and so on and so on and so forth. Right. So there's more options, space again, more options, space again, more options, and so on and so on and so forth. To quit a man page, it's Q, right? And that little page here gives you a table on how you can navigate a man page. So this is basically how do you use less, right? And so you can move forward a line, back a line, forward one page, forward backwards one page, and so on and so on and so forth, right? And so if you want to use a man page, there's information on how to use a man page. Man will actually tell you how do you use a man page if you ask it to, right? So man ls. And now if you press H down here, it will actually display that information here, right? Here's how you use ls to navigate the man page, right? So the man page is, every man page has help for the man page itself. Again, I think for most of you, it's easier to look up help on commands from the internet rather than using the man pages or the help pages. Okay, Cowsay is an example of a non-standard program, and so its man page looks different than the one I just showed you. Okay, so notice it does not look at all like the man page for ls, right? It does not list the options in a nice way. Instead, the documentation of the options are embedded in the text itself, which is really annoying, right? Cowsay, though, will let you configure the animal or the shape that displays the text. Right? So remember, Cowsay uses a cow to display some text, right? But it turns out there is a way, and if you look for it carefully, there's a -F option up here that tells you, that will tell Cowsay what shape should it use instead, right? Now, somewhere, if you search in here, and I forget how to do it because I don't use Cowsay at all. It does, in fact, oh, here it is. To list all cal files on the current cal path, invoke Cowsay. Where to go? Invoke with the -L switch. Okay. So Cowsay -L. There you go. So it actually knows how to use Cowsay with all of these shapes, to use all of these shapes. So we'll use a moose to say hello. There you get a moose, right? Oh, sorry. Okay, so two quick things and I'll let you go. Now, when you're working on the command line, it's often what's going to happen is that you'll be doing some work on the command line. You'll end up typing in some command that does something, right? So for example, when I'm generating your assignments, I use a program to generate the HTML for that program, right? The web page for that program. Problem is that command has lots of stuff I have to pass into it. So I either have to remember what is this command and how do I use it, or I can type it in once and then I can rely on the bash's history to find that command again, right? So the history command lists information about the commands you've already typed into the shell. So if I type history, right, notice it spits out this list. And if you look carefully at the list, you can see it's the list of commands that I've typed in previously, right? So the command number 2129 was the command Cowsay using the moose to say hello. If I can either go in and retype in that command if I wanted to, or I can say redo command number 2129. So exclamation mark 2129, and it redoes that command. Right. For short commands, not super useful. For longer commands, though, especially when you're doing a lot of work on the command line, it turns out to be very useful. Hey, I forgot how I did this. I can just look it up in my history and figure out and remember how to do it. And then I can repeat the command simply by typing in the number of the command with an exclamation mark in front of it. You can also access the history directly from your keyboard. So the up and down arrows will access your command history. So if I press the up arrow once, it gives me the most recent command. If I press it again, it gives me the second most recent command. And again, and again, and again, and again, and again, and again. The number of commands that are stored depends on your version of Bash and how it's configured. I don't remember how many commands mine stores. It's at least 500. It's probably more. Right? But you can scroll back and forth. So up and down will scroll through your command history, which is also handy to have. All right, so I'm out of time. We'll pick this lecture up tomorrow, I guess. Just give me a second to stop.
Like, I get.